Hello, I'm Sophie Crommelinck. I'm a PhD student at the University of Twente, the ITC. In the past 3 years, I worked on developing a workflow to delineate visible cadastral boundaries from ortho images. The workflow aims at facilitating manual digitization of visible boundaries from ortho images. And in this video, I will explain the updated version of the boundary delineation QGIS plugin that I developed within this work. So at first you open QGIS3 and then you need to install the plugin from the official QGIS plugin repository. All plugins that are in that repository you find via plugins, manage and install plugins. And then you search for the name boundary delineation, which shows you the plugin and which allows you to install it. Okay, so for this demo we will use an aerial ortho image of 25 centimeters resolution from Ethiopia, and for this we also have cadastral reference data. And as you see here, the cadastral reference data aligns well with the outline of the agricultural fields parcels that you see in this image. So to start the plugin, you have to click on the icon of the It's for Land project, and as a raster base map we will use this ortho image, and the segments layer we will load from an It's for Land project, which is basically an image segmentation that covers this ortho image. So we will load it as a segments layer. I will later do another video on how you generate this image segmentation result. So then you see that it is loaded as a segments layer, and you are asked to define a value by which it is simplified. The higher the resolution of your ortho image, the higher you can simplify the lines to without losing any detail really. So since these lines are derived from a resolution of 25 centimeters, it's fine to simplify them by 1 meter. So in the tooltip here you get some advice on how to choose this value. Then in your output window you can say where to save your output data, or if you leave it blank, a temporary layer will be created. Here you can add a length attribute to your to this data set, to the lines. You will see in step 2 why or when this is useful. And then we start processing this input data. And then after a while you get this as a result, which shows you basically the vertices wherever 2 or more of these green lines meet, and then the simplified segments which come from the image segmentation result that you had before, which are now somewhat simplified, as you can see here. Maybe it's easier to show it like this. So the green line is a simplified line. And then you have 2 other layers, the candidate and the final layers, which now contain 0 features. They will be filled throughout with the work of the plugin. And now we have enabled step 2, which I will explain in the following. So for the polygons functionality, the idea is that you click somewhere inside a polygon and the outlines are connected then to polygon. You can also select the line, and then the outlines around that line or around a selection of lines will be connected to a polygon. Then you have the possibilities to reject, accept or edit this polygon. If you reject it, you will see that the layer count in candidates goes from 1 to 0. If you accept it, you will see that the final boundary count goes up from 0 to 1. And if you edit it, the normal QGIS editing functionalities are enabled, so you can move around vertices, add new ones, delete certain ones. So basically use the standard manual delineation functionalities that you could use in a QGIS. And if you then accept your edited polygon, it will be added to your final layer. Then the lines functionality makes sense in cases where you have, for example, two lines that really delineate the boundaries that you want to delineate, but for one part of the parcel, for example up there, you don't have a green line. So then what this functionality does is it auto closes these two selected lines. And again, you can reject, accept, or edit this line. So the vertices functionality connects vertices along these green lines based on the attributes which count as a weight to find the least cost path. So within the workflow, a boundary probability is predicted. Here you see the value 0.5, which shows to which degree this line represents a cadastral boundary. And since it's used as a weight, low values represent a higher probability of being a boundary. Also, we see the boundary length that we calculated in step 1, which can also be used as an attribute to calculate the optimal path. So, to make use of this functionality, we select 2 or more vertices that are then connected along this, taking into account this attribute that we selected. So here in this case it's the boundary value, but we can also switch this attribute to the line length and then again select these 2 attributes and see that we now get a different path, which is now the shortest path connecting these 2 lines. And then the last functionality is the manual one, which works just as manual delineation, but here you can snap your delineation to the lines and the vertices to create parcels as well. When you then click Update Edits, those newly created lines will be added to your simplified segments layer, so then you can use them for the other functionalities, for example polygons. So when you finish the delineation, you can enable Polygonize Final Layer, which will turn the final layer, which are lines, into polygons. So when you then click Finish, you have the line layer and the polygon layer as well, to which you can then add attributes. And under the Help tab, you will find this video tutorial and a link to the It's for Land website, where the entire workflow is described, and you find a link to the source code and further information on the project. And if you would like to leave any comments or if you have any questions, please feel free to contact the It's for Land project or me.